Hi everyone, this is Seher from Intel. I'm from AI Framework Engineering team along with Freddy, and today we are going to present NNCF ONNX integration. NNCF is basically neural network compression framework software offered by Intel. It is provided under the flagship of OpenVINO software, and it is basically a set of compression algorithms uh, provided in a Python format, and it is used to best optimize a model on Intel hardware to be alongside used with OpenVINO software. So whether it is for CPU, GPU, NPU, we can use the NNCF offers the best performance on at least the Intel OpenVINO software for inference. So currently, neural network compression framework offers multiple compression algorithms, including weight compression for large language models or transformer-based models, and post-training quantization, and quantization aware training, quantization, pre-training quantization for PyTorch and TensorFlow models. So what we were offering until now in neural network compression framework was uh, on OVIR model. Basically, OVIR model is the representation for OpenVINO framework. So now we have extended this capacity to include the ONNX model representation also. So in the back end and in the front end, we both have ONNX model ONNX model as inputs and outputs. So what we can do is that when we are running an NCF to quantize a model, we can use ONNX as the input model, and we can also have the compressed ONNX model as the output. Currently, we are introducing two new APIs, at least one new API, which is nncf.compress_weights. So this is very useful for LLM. We had an NNCF.quantize earlier also, but it was mostly in an experimental format. Now we are extending it to include a much larger set of models. And this is a normal post-training quantization algorithm that we can run with calibration data set on an ONNX model and get a compressed ONNX model. And the compressed weights is basically introduced for LLMs and transformer-based models. It is also data-aware quantization. It also offers data-aware quantizations for some of the algorithms like the AWQ and scale estimation. And the output is a compressed ONNX model, which can be downstreamed to be deployed either through OpenVINO ONNX frontend or through other ONNX deployment software like ONNX Runtime. Uh, this is the new offering that we are offering for NNCF ONNX workflow. Up till now, we were going through a roundabout way where we were taking an IR and we were encapsulating into the EP context nodes and passing it downstream. But now with this new integration that we have, we are directly able to compress the ONNX models. The implementation and the APIs are very straightforward, very simple. They are all uploaded in the NNCF GitHub repo in the examples, and you can all go through there. We have a tiny llama compression. We have tiny llama compression with the scale estimation, and we have also recently added FP8 data type to the compressed weights algorithm, so API. So we have a small LLM from Hugging Face that works with that FP8. So please go through it. The APIs are pretty straightforward. We take a model, we export a model from Hugging Face using ORT model for causal LLM APIs. It's basically an Optimum ONNX API, and we can store that ONNX model locally. And then we also, if you are doing a data-aware compression, we can take a subset, we can download a data set. Here we are doing a Salesforce Wikitext data set. We have other optimizing arguments here that we can give, like subset size. I'll cover the different configuration parameters that we can pass to the compressed weight API. And so we have different arguments there that we can provide to achieve the best quantized model that we want to. Then we run the nncf.compress_weights API. If we are running a post-training quantization, we run an nncf.quantize API. function call. And yeah, we finally returned back an optimized model in an ONNX model proto format, which we can directly save to the local directory. So this allows us to, earlier we were, we were converting the model to IR. So all those steps are eliminated. We don't need an IR model here. We can, the input to the NNCF model, NNCF APIs and output will both be ONNX formats. Let me go through the various arguments, various options and configuration parameters that we provide to these two APIs, NNCF quantize and compressed weights. First, of course, the mode, we support a large variety, a large range of modes. So we support int8, int4. Currently, we have started supporting FP8, FP16, of course. FP4 and NF4, these are the major two ones that we don't currently support. But yeah, other than that, we support a lot of data types. We have the ratio. So ratio basically specifies what percentage of layers that you want to compress. So there might be some, in an LLM especially, there might be some critical layers, activation layers that you do not want to compress because it might lead to a huge degradation in accuracy. So uh, uh, that we can provide with through ratio. We can provide with what is the level, what is the percentage of layers that we want to compress, say from to int4, and the rest we maybe want to leave it to int8, and that we can specify in the backup mode if you want to leave the rest of the uncompressed layers to int8. The group size, basically we support group-wise quantization. So if you want to say support into n number of, if you want to specify an n number of group level of quantization to improve accuracy, then you can, specify the group size. Ignored scope is very useful because it tells you what layers or what components to basically disregard. So if you want to say disregard gather operators and you do not want to compress it, you can give those in ignored scope. All layers, true and false, give if you want to compress all layers. So it's basically true if you want to compress all layers, or if you want to leave a level of layers, uh, layers off, they disable some layers, then you can say all layers false. Data set, again, for NNCF quantize, it is the calibration data set. You can give a data-free compressed weight, which will compress weights without data. But if you want to have a data-aware compression of weights, then you can provide data set in the compressed weights API also. It is especially useful when you are doing an AWQ scale estimation, utilizing an AWQ scale estimation algorithm. We have the sensitivity metric, which basically, so if you say like in a ratio, if you give like 90% of compression that you are, 90% of layers that you are compressing and 10% layers you're not compressing, then it measures, and then basically you want to ignore the most sensitive layers that lead to accuracy degradation. And how do you determine which are the most sensitive layers? So you determine that by sensitivity metric, which basically specify the mean variance or max variance algorithm that you can use to determine the sensitivity of the layers. Then you have the AWQ and the scale estimation compression, basically, which allows you to uh, uh, apply different compression algorithms and different algorithms to the compression, the LLM compression. Then you have preset and fast bias. I wanted to cover this because it's used for an NCF quantize, which is the quantization method. So preset basically, if you set a preset to say performance mode, then it will only be like a symmetric quantization. But if you say it's a mixed one, then the activations will be asymmetric quantization, so that you can have a trade-off between accuracy and performance. And fast bias correction is also for the quantization layer, because if you go through layers and you quantize through layers, there's a bias introduced, there's a drift introduced. And if you're trying to correct that bias during inference time, it takes a lot more time. But if you're doing a fast bias correction, you can, during quantization itself, you can correct the bias depending, looking at the previous layer. So this is one of the algorithms that was introduced by Intel team to improve the compilation and the quantization of the models. Yeah, going forward, want to, so all these options are present in the NNCF software API, which is the GitHub NNCF repo and the Python package of NNCF. You can go and check it out and start using it. We have also started integrating NNCF toolchain into the popular NNCF tool into the popular ONNX community toolchains like Olive and Optimum, so as to allow developers to basically uh, ensure that they have a seamless um, flow in place, uh, uh, and they can directly use NNCF with Olive or with Optimum ONNX tool chains instead of installing a new tool chain separately and copying the model and basically switching between different software frameworks, right? So we already have the Olive toolchain integration with an NCF quantization pass. So I think it's if the olive.json file, if you can give an ORT quantization pass. Similarly, you can give an NNCF quantization pass. I'll go through this the flow of Olive and NNCF quantization integration in more detail in the next slides. For Olive, we already have a integration with NNCF in place, and it can be used for ONNX models. Until now, we had an optimum Intel NNCF integration in for OVIR models, not for ONNX models, and it was working quite seamlessly, and it serviced a large set of Hugging Face models that we had. So what we are proposing now and that we are going to upload now is Optimum ONNX and NCF toolchain integration. So right now we have the ORT optimizer that is integrated with the Optimum ONNX when we go to optimize or quantize commands. So we are also exploring adding NNCF quantize toolchain and NNCF optimize tool there as a command. So instead of taking the model and then installing an NCF and switching between frameworks, we can have a end-to-end Optimum ONNX and NCF toolchain integration there. To do this, we will have the Optimum Intel dependency on Optimum ONNX and invoke Optimum Intel through Optimum ONNX to make sure that we can invoke an NCF for quantization directly from Optimum ONNX. So I'll go through the Optimum Olive NNCF integration, which is already in place and can be used through open source community right now. So of course, the stage one is the input. You export a Hugging Face model or PyTorch model. You export a calibration data set that you need, and you prepare an olive.config.json file where you give an NCF quantization pass as the quantization framework that you want to basically enable. Then you go through the Olive workflow orchestrator, which basically invokes an NCF quantization pass, and it identifies the hardware target that you want to select. I just want to say again that NNCF supports all CPU, GPU, and NPU hardware targets, and it is one of the best tool chains that can give you the best of performance on any of these hardware. So highly recommended if you are using any of those AI accelerators like iGPU and NPU from Intel. Then once we invoke the NNCF optimization pass, the flow moves to the NNCF tool chain, and where we wrap the model in an NNCF network graph, NNCF TNN graph, and we do a computational graph analysis and layer detection. So stage 3 is where the NNCF core quantization happens, and if you have selected, say, PTQ, post-training quantization or compression weights, the algorithm selection happens. NNCF uses fake quantization nodes insertion into graph, and it also offers QDQ data QDQ model type if you're doing quantized nodes, creating a QDQ model. Then Olive allows you to export to ONNX with quantization nodes and then do an optional open, IR export if you want to do an IR export. You can evaluate the accuracy evaluation baseline, which Olive offers, do a latency benchmarking, and if your accuracy is under threshold, yes, you move to the 5th stage, which is the export stage, which is final ONNX export stage. But if you want to reevaluate with Olive the accuracy, you go back again and start the precision mapping again. So yeah, this is the Olive flow. Finally, when we are in the output, we have a quantized ONNX model, we have a quantized config JSON, and the performance and accuracy report with what we executed. So yeah, this is the Olive tool chain, and I think it's done. If you want to explore more, you can refer to NNCF examples in github.com OpenVINO toolkit. We have NNCF repo. We have examples there for LLM compression, llama compression, scale estimation. And we also have object detection, post-training quantization examples for vision models. If you want to do installation and usage, we have repos for that. Documentation, we have OpenVINO notebooks that have a lot of examples on NNCF quantization. And if you want to explore Olive and Optimum, we have documentation of that. So yeah, this is all that we have. Any questions? Thank you.
Thanks. Any questions?
No, there's something in the bridge.
Sorry.
Does not check.
So I have a question. So do you recommend to use it within the Olive framework or more like the NCF, or is exactly the same, or is one has more functionality than the other? Can you just specify a little bit? Because it seems like you described two approaches.
It depends upon your flow. It can be either used through Olive. All the configuration parameters that are available through NNCF are also available through Olive, and it can be set through the JSON configuration, JSON arguments. So it depends upon the workflow that you're using. If you're already using Olive and you want to add another pass to it, especially if you're already using ORT quantizer with Olive and you want to explore whether NNCF will give you better performance, you can definitely try that one out. And NNCF as a tool is quite useful when it comes to other quantization algorithms also, especially pre-training quantization, and if you want to explore with OpenVINO IR also, that NNCF has more options, and you can explore that if you want to have a best performing model.
And how much is dependent on being able to run the model?
So once you have an ONNX model, you can run it through OpenVINO, or you can run it through other ONNX deployment software, say ONNX runtime. So there is no dependency. Once you have an ONNX model, you can run it as you will run any ONNX model. And both OpenVINO and ONNX runtime have the inference to run the ONNX model. NNCF will not do inference. NNCF is only for quantization. So when
you quantize, you never need to run the model?
So the NNCF will quantize the model, and when you are deploying it, you deploy it with OpenVINO. It's the same. It's same open source software that is available.
Yeah, depending on the workflow, like I think Olive will actually do some model execution after it quantizes it, right? You have the option to skip it, but
yeah.
But technically you should be able to just quantize and compress without having to run the model.
Okay.
Okay, thanks a lot. Thanks everyone, and I think we have run into the break significantly, so we'll take a 12-minute break at this point and